Hello and welcome to session 15 of the MMO development class. So today we are going to be kicking off where we left off with CGS, which you guys recall was getting our tree grammar working. So at this point we have our tree grammar working, and we can see that it's working because, well, we have our style sheet builders being invoked properly when we run uncompiled CGS through our compile process. Now right now these tests, I know they look kind of silly, I'm testing basically for the same string, but it's important to understand what is happening in between this. What's happening in between this is that the code that we wrote in ANTLR is invoking methods on our builder interfaces. So what I want to do today is I want to step back and actually write the implementation of our builder interfaces and of our selectors so that we can, well, get some selector action going, I guess. Okay, so what I'm going to do is I'm going to create a new project. And this project is going to be a class library. It's going to be called CGS.engine. And what CGS.engine is going to have inside of it are just a bunch of implementations of our builders so that we can test our selector stuff. So how's everyone feeling about that? Hopefully they're feeling awesome about it as I stall for time. Okay, so what I'm going to do is I'm going to create a internal namespace. Inside the internal namespace is where I'm going to put the implementation of all of my selectors and selector builders and all that fun stuff. Now, inside of the internal namespace, however, I am going to have internal classes. I don't want these classes that I'm going to be writing are going to be hidden behind all the interfaces. I don't really want them exposed. That presents us a problem because I'm going to be unit testing all the classes that we write, and the unit tests are in a different project. If you aren't familiar with internal accessibility means that that class can only be viewed from within the same assembly. Now, fortunately, there's a way around internal visibility, and that's through the use of an assembly attribute called internals visible to. So it's sort of like a whitelist saying the following project has access to the internal types in this project. So I'm going to add that attribute to my assembly info.cs file underneath the properties folder, and the assembly attribute looks like this. We have assembly followed by internals visible to, and then I pass in a assembly name, and that assembly name is going to be cgs.tests. So now that we have cgs.tests added to the internals visible to attribute, we can now write internal types inside of cgs.engine and test them inside of our test project, but they'll still be hidden from every other assembly, like what we want them to. So let's start with something simple. Basically, what a selector is a selector is just something that allows us to match a particular element. But we don't currently have a representation of what an element is yet in our code. So let's go ahead and write that first. I'm going to jump into cgs.base, go under abstract, and I'm going to create a interface called iElement. iElement will represent an element in CGS that can be matched against a selector. A couple properties that I'm going to throw on this, I just know I'm going to need them in the future based off experience. I need a unique ID, first of all. The unique ID is going to be a sort of string that represents this element in a selector sort of syntax, if that makes sense, and it's going to be used to cache styles, because we need to be able to construct styles from elements, but because that process might be computationally expensive, we need a way to cache the styles that we've created for elements, so we need a unique way to reference each element. Next up, I'm going to add an ID. Every element can have an ID. Next up, I need a parent. Every element, just like in HTML, can be parented to another element. Next up, I need an element type. Every element has a type. Then I need two enumerable of strings. One for my classes that are applied to the element, and one for my pseudo classes that are also added to this element. So pseudo classes. And if you guys recall, a pseudo class could be something like whether or not it's active or hover over or whatever. So that'll keep track of that information for us. So now that we have that, we need an implementation of our element interface. Now, what I'm going to do is I'm going to provide an implementation of my element interface inside of CGS.base itself, because this element class is going to be used pretty much everywhere anyway, and there's not many different things we can do about whether or not it has a unique ID or... it's just, look at it, it's just a container for data. So we have our unique ID, our parent, and our type. Those are all automatic properties with private set. That's all good. For our two enumerables, I'm going to create two corresponding lists. A list of string for my classes, and another list of string for my pseudo classes. Then my properties are simply going to return a reference to either one of these things. Okay, so I'm going to need to create a constructor, and I also want to create another constructor that makes it just a little bit easier to create our elements. So I'm going to create a constructor that takes in an element type, an ID that defaults to null, a class that defaults to null, a pseudo class that defaults to no, and I don't think I spelled that right, did I not? Pseudo. Wow, Pseudo. Then an element parent that by default equals null. And we'll see how this all comes together very, very shortly, so just bear with me for a second. But I need this thing written first before I can actually go on and start writing my tests for my selectors. So what is this going to do? It's just going to say ID equals ID, type equals type, parent equals parent. Then I'm going to say if not string is null or white space class. Then I want to say pseudo classes.add class. And then I want to say if not string is, whoa, why did I do pseudos there? Pseudo class, which I'm actually going to rename this parameter to pseudo class to be a little bit more specific. And then I'll go and say pseudo classes add pseudo class. And that's all I need for now, except for I do need to go ahead and create a unique ID. So currently I don't have any way to generate my unique ID. Generating the unique ID is just going to be basically taking everything, all the information that we have and putting it all together. So I'm going to write a little helper, a private string generate unique ID. And what I'm going to do, actually, I'm going to keep this as void, and I'm going to say generate unique ID upon creation of the element. And what that's going to do is it's going to set my unique ID property to, well, the unique ID that's computed based off all these other values. I'm also going to make these private fields read-only. So this is going to be unique ID equals, we're going to have our element type, oh no, we're going to have our parent, followed by our element type, followed by our ID, followed by our classes, followed by our pseudo classes. So unique ID is really just a combination of all these other things. So let's go ahead and write out what we need to do here. So the first thing I need to do is I need to prepend on my parent, but only if we have a parent. So I'm going to say if parent does not equal null, then I want to say parent.uniqueID. So I want to append on the unique ID of the parent. Otherwise, I want to do nothing. Next up is I need to put in my type. So I'm going to just dump in my type right there. Remember that our type has a toString member. Our element type class has a toString member that just returns the type that it is. So that's good. Next up, we need, after we have our types, we need our element or our ID. So what I'm going to do is say if not string is null or white space ID, then prepend a hash to it and type it out. Otherwise, just do nothing. Next up, we have our classes. So how do we do our classes? Well, classes can just be done like, let's see here. We need to first check to see if we have any classes. So I'm going to say if classes.any. If we do have classes, then I want to do a dot followed by a string.join on dot followed by our classes. Otherwise, we want to do nothing. So this is just going to make, if we have classes attached to this element, then it'll make them with or it'll print them out with a period delineated list. So it's going to look very similar to a CSS selector, and that makes it very easy to debug and work with. Finally, we have our pseudo classes. Our pseudo classes are going to be very similar, except for they are actually delineated. If you guys are familiar with CSS, they're delineated by colons. So with this code, basically all we're doing is we're generating a unique ID for an element, and that's going to be useful for caching our styles as we generate them. So now that we have our element class and our element interface, we now need to know how we're going to go about selecting our things. So that's where things get complicated. Let's see, I'm going to set this as a startup project just because I don't like the ugly bolding right there. And I'm going to, under internal, I'm going to go ahead and write our first selector. And the selector is just going to be a class. And the way that I made this is interesting. It's kind of complicated, but sort of out of necessity, just because what Hello? I'm here. I hit the wrong button. Okay, I'm going to create an abstract namespace, and I'm going to put a abstract selector in there. And he's going to be an abstract class. The first type of selector I want to implement is a class selector. So I'm going to create a class selector. So let's look at this selector first. What's the selector going to instantiate? Well, this is where things are going to get a little tricky. A selector needs a parent. And this is going to be fun. Let's just start off with the basic definition of our selector. What we need is we need a public Boolean method called matches, and it needs to know if this selector matches a particular element. Oh, come on. There we go. And we need to return either true or false if this element is matched by this particular selector. So right now I'm just going to say return true. Then I'm going to create a class selector that inherits from selector. And a class selector is going to have a constructor that takes in the class that it is selecting off of. And so far, that's it. All right. So we have our class selector object, or a class that inherits from selector. So let's go ahead and write a test to see if we can get stuff to sort of start coming together as far as how this API is going to look. So I'm going to create a selector tests, and I'm going to mark this as a test fixture, and I'm going to write a first test, and I'm going to say public void class selector matches single element with same class, and this is going to say var selector equals new class selector, which is going to necessitate that I import CGS engine into my project, and I'm going to give it a class of test. Then what I need to do is I need to see if an element gets matched by it. So I'm going to create a new element. I'm going to give this an element type of, I don't know, h1, and then I'm going to give it a class of test. Then I'm going to say selector matches element should be true. Right now, this test will actually pass. It'll pass because I put in my matches always returns true, but obviously that's not desirable. I want to write another test that says class selector does not match single element without same class, and I'm going to create a new class selector with the test2 as an example. And then I'll run this test, and I should get a failure. And I don't get a failure because I forgot to actually switch my assertion over to being false. And I get a failure. There we go. That's what I wanted. So I need to go ahead and write a class selector implementation that will match if the element passed into his matches has the same class as what I instantiated the class selector as. I'm also going to go ahead and visualize each one of these examples using basic HTML syntax. So in this case, we have an element of type h1 with a class of test, and then we have a class selector of test. So this selector should match this element. However, if I were to visualize this one, in this case, we have a class selector of test2, so this should not match this element. So let's see about making these two tests pass. For right now, what I'm going to do is I'm going to make the matches abstract. And then I'm going to provide an implementation in class selector, and I'm going to return if element.classes contains the class that this class selector works with. I'm actually going to switch class over into a private field. I don't want class to be a property. I want it to be a private field. Okay, so our class selectors work. Let's introduce some nesting. I want to go ahead and introduce the concept of nested elements early on because that's going to significantly change the implementation of our selector engine. So I'm going to copy and paste this. I'm going to say nested element with class gets selected. And how do I represent a nested element? Well, I'm going to go ahead and write a UL and an LI inside of it, and the LI is going to have a class of test, and my selector is just going to be test. So what this means is this selector should match this LI, but not the UL. So let's go ahead and write our UL element with an element type of UL without any classes, and then I want to create an LI element of new element with a new element type of LI, a class of test, and a parent, class of test and a parent of UL element. So the selector should not match the UL, but it should match the LI. and we get an error. Expected to be true or found false. The selector should match the li, so it's not matching the li at all for some reason, even though I thought it would work. That's why we write tests. Okay, so the first thing that comes in is an element of type UL with no classes. This should not match. The second time we get is an element with the class of test. Oops, I forgot to change my class selector. Okay, so that's not very interesting at the moment. Let's write a more interesting test. So nested selector with class gets selected. So what I want to do is I want to give my UL a class of parent and the li a class of child. And I want to write a selector with .parent.child. So how could I represent this selector with my code? Well, currently I can't because selectors currently don't take in parent selectors. So let's fix that. What I need to do is I need to write a class selector that takes in another selector of a parent and saves it somewhere. So now when I go in, oops, I want to default my parent to null. Now when I go in, I'm going to say, okay, I have a class selector of child with a parent class selector of parent. And then I have a UL with a class of parent, and then I have an li with the class of child. Now, my selector should match my li element because my li element is indeed nested, but it should not match my ul element. Let's see what happens. Wonderful. We're getting a test when we shouldn't be getting a test, or getting a success. Okay, come up with a test that'll actually fail, guys. Come on. Oh, I know. Let's introduce a third element. So li element 2, which is a new element with an element type of li with the class of child without any parent. So now I'm writing another element that doesn't have any parents. So the selector should not match this one. So that's like if I wrote another element here, li with a class of child. There we go. Finally got a failure. Okay, so what's going on now is our selector has no concept of being nested within itself. So we have to actually back out and think about how we can traverse the DOM, I guess you could say, actually, as well as the selector. I have a particular way that I ended up writing this earlier, and it took me a while to come up with this algorithm, but it seems to have worked very well. And so I'm going to use this algorithm. And what it's going to involve is my selector, my actual selector class is going to have a protected constructor that takes in a selector parent. And then the matches method is no longer going to be abstract. What it's going to do is it's going to create two what I call chains that it's going to use to traverse. So the first chain is going to be a chain of elements, and the second chain is going to be a chain of selectors. And then what it's going to do is it's going to traverse each thing item by item by item, ensuring that each bit of the chain actually matches up with what it should until it either reaches a failure, in which case it returns false, or it reaches the end of the chain, which means that it returns true. So let's go ahead and do that. What I'm going to do is I'm going to write two methods, getElementChain and getSelectorChain, and they're both going to return a linked list. So I'm going to write a private linked list of iElement called getElementChain from iElement, and then this is going to be the child. So what this is going to do is it's going to create a new linked list of I element. Then it's going to enter a do while loop, and it's going to say this should be elements. While elements add first child equals child.parent, while child does not equal null, return elements. So what's going on here? Well, we're basically going to get back a linked list that shows the entire hierarchy of the element. So we're turning a tree structure into a reversed list. And we're going to do the same thing with a linked list of selectors. This is going to be get selector chain, and that's going to receive nothing because the topmost selector is actually us. So this is going to be a new linked list of selectors. Then what we're going to do is we're going to enter another do while loop. I'm going to set my I'm going to create a temporary variable outside of it called root of type, or sorry, of this. Then I'm going to say selectors.add first root equals root.parent, while root does not equal null, return selectors. So we're getting two linked lists back, and they're going to both start off at the beginning of the hierarchy. So you remember, the objects that we're looking at right now, when we pass it into the matches method, are the children. So this is the object that we're actually passing in to the select method, and this is the object we're passing in, or we're invoking the select method on. Which means we need to traverse the entire hierarchy of how this element appears inside the DOM or inside of the selector model, and we need to turn it into a linked list that starts with the topmost of either thing, either an element or a selector. So that's what these two linked list methods do. So what I'm going to do is I'm going to write another private method, private static bool, and this is going to basically match or traverse the entire chain of both of these both these chains is going to traverse and make sure that every step matches with what it should match with. So it's going to make sure every element matches with the current selector we're looking at, and their pseudo elements match and all that fun stuff. So this is just going to be chains match, and it's going to take in a linked list node of I element. I'm going to call this element pointer. Then it's going to take in another linked list node of selector called selector pointer. Element pointer and selector pointer are basically what we're looking at currently while we traverse this linked list. So then what we're going to do is I'm going to enter another do while loop. I'm going to say do while, and I'm going to say while our element pointer is not null, while we haven't reached the end of the element. If we ever do reach the end of the element pointer without reaching the end of the selector pointer, then we return false because we know that this element doesn't match the selector chain. Okay, so next up we need an element. So I'm simply going to alias out element pointer, and I'm going to alias out selector pointer. And then I need to check to see, okay, does this selector match this element? And I'm going to say if selector, and I'm going to create another method, not a matches method. I'm going to create a does match method that takes in an element. And I'm going to create that in a second here. What this is going to do is if this does not match, if the selector does not match the element we're looking at, then we actually don't care. We can just keep on going. It doesn't matter. But if it does match, then we need to move our element pointer up once. So we're going to continue that, and then we're going to continue our loop. Okay, so I hope that this is not too crazy. Anyway, so I'm going to go ahead and implement my doesMatch. And doesMatch is going to be a protected abstract bool method. And the protected abstract bool method is going to be implemented by all the children of the selector class. So a class selector will have his own matching logic, the ID selector will have his own matching logic, and so on. Okay, so let's think about this. If selector does match element, then we move the element pointer forward. Now we have to figure out, well, how can we figure out if we moved forward? Let's see here. Or how do we exit out of this loop appropriately? So if the selector doesn't match this element, then we have to move our selector pointer forward. If it does match, we continue until it doesn't match, and then, wow, I'm even confusing myself here. Thinking. We have to move our selector pointer forward. Even if it doesn't match, we have to move our selector pointer forward, do we? No, if it doesn't match, we should exit out. Well, not necessarily, because if it doesn't match, then we should move our element pointer forward. It doesn't match. If it doesn't match... Oh, I got this backwards. If it doesn't match, we move our element pointer forward. There we go. That's what I was sitting there thinking. Is like, Okay, so if it doesn't match, we move our element pointer forward. If it does match, we move our selector pointer forward. And, whoops. And if we've reached the end of our selector pointer, then we return true. So if we've traversed the entire chain of our selectors, we know that we can return true because this selector ultimately matches. Okay, so then the matches method becomes implemented like this. We return chains matched, we get our element chain based off element, and we get our selector chain. And we pass it into this. Oh, and then I have to do dot first. Dot first. Okay, so now we have our abstract doesMatch method that's going to be implemented on all of our children of selectors. So I'm going to jump down into my class selector, and I'm going to implement doesMatch. DoesMatch is going to be exactly what we had before in matches. The second thing I need to do is I actually need to, because our base selector class now has a parent in the constructor, we need to pass that in through our constructor of class selector. And it works. Okay, let's make a little bit more complex example. I'm going to go ahead and write a selector that goes parent, child, grandchild, stuff, and things, and whoa. So that means the only way to match this selector is to have an element that's parented in this hierarchy. Which, let's go ahead and take a look at how that would look if this were written in HTML. So this would be grandchild, this would be stuff and things, this would be, and whoa. So just tossing a really contrived example at our test and seeing if it works. So let's see here. I'm going to go ahead and remove all that. And first I'm going to build up my selector. So I'm going to have a class selector with a nested class selector with another nested class selector of grandchild. And then this one is going to be stuff and things and this one is going to be and whoa. So here's how we would instantiate the selector that only matched an element that was parented, or that had the class of child, that was parented to an element with the class of parent, that was parented to an element with, or the other way around, is what I'm saying. See, the order kind of gets confusing sometimes. Okay, let's make an example of an element that should match. So I'm going to say, here's our parent element. It's a new element with the type of, let's just do, let's match my comment. So type of UL and the class of parent. So we have parent, we need child, grandchild, stuff and things, and whoa. So parent, child, grandchild, stuff and things, and whoa. Child is going to be an LI with the class of child. Grandchild is going to be a span with the class of grandchild. Stuff and things is going to be a span with the class of stuff and things. And whoa is going to be that. And now I have to parent them. So child is parented to parent. Grandchild is parented to grandchild, or child. Stuff and things is parented to grandchild, and whoa is parented to stuff and things. So that means my selector should match and whoa. Because there should be, no there isn't. So should be true. Oh, there's a be true, isn't there? Okay, so this should be true, and then everything else should be false. Because I'm going to also match stuff and things. I'm also going to match grandchild. I'm also going to match child, and I'm also going to match parent. So let's see if this ridiculously contrived code works. And we get a failure. So it expected true but found false. Selector does not match and whoa. Well, here's a great way to debug this sort of stuff. What I'm going to do is I'm going to write out, I'm going to say element blah not matched by selector. And element blah, remember how I wrote that that unique ID? That'll give us a good idea to make sure that we've actually constructed our hierarchy appropriately. And then I'm going to pass in selector. So now let's see what the error message is. Expected true because element ul.parent, li.child, span.grandchild, span.stuff and things, and whoa was not matched by class selector. Well, why not? I bet I have a spelling error somewhere here. Give me a sec. Oh, wait a sec. I created my class selector the wrong way. Child, I should have started with and whoa. So and whoa goes into stuff and things. That goes into grandchild. That goes into child, and that goes into parent. And I get a ridiculously contrived class example. So that's cool. Let's go ahead and quickly implement out the other basic selectors. We need an element selector and an ID selector. So I'm going to write an element selector, which implements selector. Element selector is going to take in an element type and a parent. And then his does match method is simply going to be return, said I want things to be case insensitive, so I'm going to say return string.compare element dot type and type with current culture ignore case. And this has to equals, actually I think I can do string.equals, can I? Yep, I can just do string.equals. Okay, so there's my element selector, and then I want an ID selector. ID selector is going to be a selector. I need a constructor generated. It's going to take in the string ID. It's only going to match if the element passed in matches the same ID. So that's easy enough. I can just say return string dot equals element ID, and then pass in ID, and then pass in current culture, ignore case. So I have an ID selector, an element selector, and a class selector. Let's write some basic tests for my ID and elements, and then let's combine them with more advanced or more complicated examples with combining them with class selectors. So ID selector does this ID selector matches, and then we need an ID selector. The ID selector is going to take an ID of my thing. Also, I want to default in the constructor. I want a default parent to null, so I don't have to provide that parameter. This element is going to have an ID of my thing, and then they should match. So there's my basic ID selector, and I can toss in two elements. I'll have an element and an element 2. Element 2 will have a my thing 2. Selector should not. So this should be true, the other one should be false. Then I'll do an element selector. An element selector takes in a new element type. Let's pass in h1. And then just like what I did with ID selectors, I'm going to make element selectors have parent defaulted to null. Okay, so this should match. And then I'm going to create another element that should not match. This is going to be an h2 with the same ID. I expect these tests to work just fine, honestly. There we go, they work. So let's make some more complicated examples. Now I want to create a selector that has child selectors that are not all the same type. I want to create child selectors of like ID selectors and element selectors and all that fun stuff. So I'm going to write another test for public void nested child selectors of different type matches element. So I'm going to write out in comments first what I want to select. I want to select a UL with the ID of, how about navigation? Actually, I have a better idea. I'll create a nav element with the ID of primary, then a UL element, and then an LI element with the class of active. And then I want to write a selector that will match just this one LI and not the other LI. I'm going to introduce two LIs into this. One with the class of active and one without the class of active. So the selector that I want to write is going to be primary UL active. So let's go ahead and write the selector first. The selector is going to be a new class selector with the class of active and a parent of an element selector with the element type of UL, and that selector is going to have a parent of an ID selector with the ID of primary. Okay, so let's write our elements. I have two elements I want to write. So let's first do our parent element. Our parent element is going to be a element with the type of UL and a parent of a new element with the type of nav and the ID of primary. Then I want to do child1 is a new element with the type of LI and the class of active. And the second child is going to be an element like this that does not have this, and I also need to appropriately parent it up. So I need this, both these children elements share the exact same parent. Okay, so selector matches child1. This should be true. Selector matches child2 should be false. Now let's see what happens. And we get a passing test. Okay, so that's a really, really basic example of selectors. We already now support some fairly complicated selectors, but we have two things that we need to fix immediately, and I'll show those. I want to have a combined selector of different types matches element. What that means is I want to select a nav with the ID of primary and an li with the class of active. So how do I represent combined selectors where I have a element selector plus an ID selector, or an element selector plus a class selector? How can I go about doing that? Well, the current way the code is, this actually actually I have no way to represent this in the first place, now that I think about it. So what I need to do is when I parent a selector, I need to give it a relationship. I need to know if the parent selector is separated by a space, separated by nothing, or separated by a greater than, because that affects the behavior of my matching logic. So let's go ahead and write the code that will allow me to specify the relationship between selectors. To do that, I'm going to create a enum of selector relationship. And this relationship is going to determine the relationship of the parent selector that a selector is looking at. And there's a couple of them that I need. First of all, I need an immediate descendant. I need a descendant. So this is separated by that. This is separated by space. And then I need a none, which is separated by nothing. A selector relationship of none means that that selector appears immediately after the other selector without any sort of space or symbol. So I need to introduce the concept of selector relationships straight up into my abstract selector type. So I'm going to do that up here. I'm going to say selector relationship. However, that's going to break my class selector and my element selector and my ID selector because I now have to pass in that parameter into my parent. So let's go ahead and do that. I'm going to say parent null selector relationship equals how about none? We'll default that to none. So I'm going to go ahead and take this code and I'm going to paste it into element selector. Parent relationship. And then I'm going to put that into ID, this guy as well. Okay, so now I am capable of specifying to CGS how I want my elements to be related to each other. And currently it defaults to none. I think actually I'm going to change that default to descendant to make my code a little bit easier to read, because 90% of the time when you describe a parent selector, you're really talking about a descendant selection, not a none. But I want to be able to override that. So if I jump back into my selector tests, this test is going to become a little bit interesting. So we have a new class selector of active, a new element selector of blah, that has a new ID selector, and I want to alter my relationships. So first of all, my nav, or my primary ID selector, is now a little bit more complicated. Not only is an ID selector a primary, but it has a element selector parent of nav, but more importantly, it has a relationship of none. So this is kind of like a compound selector, I guess you could say. I don't know what the actual W3C terminology of this is, which I'm sure I've violated that terminology multiple times so far, but regardless, I can now describe this kind of selector to my code, which is what I want. That also means that my active selector becomes a little bit more complicated too, because now he's going to have a new parent of element selector with the element type of li, and he's going to have a selector relationship of none as well. Okay, this is where things are going to get really tricky to show in code. So blah blah blah. Element type. That's passed to you. The li needs to be parented to you guys, I think. Most likely. Maybe. I'm going to rewrite this. This is getting awful. Okay, a selector. Let's start off with what we need. We need the first thing, remember, we're constructing this object from right to left. So, first thing we need is a class selector with a class of active. He has a parent selector of type element selector. This element selector, his relationship to the element selector is none. The element selector has a... See if I can come up with a sensible way to format this monstrosity. Okay, the element selector has a element type of li. His parent is another element selector, the element type of ul, but this other selector does not have a relationship, or it has a relationship of descendant, which is the default. So I can keep the relationship there, not defined. Then this ul element selector has a ID selector of ID of parent with the relationship of none. The ID selector has a parent of a element selector of nav with an ID with the relationship of none. There we go. Element selector nav none. Okay, so here's my hierarchy. So the selector should match child 1, should it parent is a type nav with the ID of primary, then he's parented to a UL with nothing on it, that's parented to an LI with class of active, and so on and so on. Okay, sweet. So let's introduce another element that won't match. And that other element that won't match is going to be a span with the class of active directly inside of my UL. So I'm going to create a third child. This child is going to have an element type of span, but it's also going to have a class of active. Now, this selector should not match child 3. But I have a feeling it's going to break everything. Yep. Expected true but found false. Let me go ahead and let's see here. Let me go ahead and see if that actually, this hierarchy is actually even being built right. Selector has a parent of element selector. Relationship of none. That has a parent, descendant. Okay, that looks about right. Okay, So now we have to figure out a way to make it so that our chain matching, when the next selector in the sequence has a relationship of none, that means that let's see here, that means we don't want to move the element forward. Which we don't do anyway. Let's see here. Actually, we should always move the element forward if it's a descendant. If it's a descendant, we do move it forward. If the relationship is a descendant, we do move it forward. If the relationship is a none, then we don't move it forward. So what I can do is I can say if the selector that we last were looking at has a relationship to its parent of none, or does not have a thing of none, then we move it forward, or don't move it forward. Whatever one means the correct thing. Okay, so it says expected true but found false. Let me quickly make sure that my test is actually let's do element blah child1 dot unique ID. Let's see here. Nav primary ULLI active. Okay, so let's go ahead and NATO, yes, that shouldn't be too difficult to do. Let's see here. Let's go ahead and to ease debugging a little bit with my selectors, I'm going to introduce a toString method on my selector class. So I'm going to override toString, and toString is going to return the string representation of my selector. So what that's going to do is I'm going to say var builder equals new string builder. Then I'm going to say for each var selector in get selector chain. I'm going to reuse that method right here. And then I'm going to say, now I have to put in my proper relationship bits in here. So I'm going to say if the selector's parent does not equal null, then I need to append something to it, and that something is determined by the type of relationship. So I'm going to write a helper method, get relationship, or get string for relationship, selector dot relationship. Get string for relationship is going to return a string, not a character. I'm going to say, I'm just going to go ahead and switch on relationship. An immediate descendant will return this. A descendant will return a space, and a none will return a blank. Or a blank. There we go. Okay, and I'm going to dump this method all the way at the bottom and make it static. Okay, so then I'm going to say builder append. Now I'm going to have to write a method that will be inherited or be implemented by every single child class of selector that gets the specific textual representation of a selector. So I'm going to say get textual representation of selector. This will also help us debug our concrete implementations of selector builders as well. Get textual representation of selector will be a protected abstract string method. And then at the end of my toString, I'm going to return builder.toString. And then I'm going to toss toString all the way at the bottom as well, even though it's not private, but I don't really care much for seeing that all the time. So now I'm going to go ahead in my class selector and I'm going to return the textual representation of a class selector, which is always dot followed by the class we're selecting on. The element selector, the textual representation of an element selector, is simply the type. And an ID selector is simply going to be a pound. So now my tests, element blah, selector blah, should be a lot easier because now I can just pass in the selector straight into this and see what the textual representation of it is. I wonder if I can throw in a new lines into this output. It'll make it a lot clearer to me. Yep, I can. Sweet. Or no, I can't. Something. Whatever. Because element... okay, that's correct. The selector is... Whoa. Active, 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 active. Huh. That's not ideal. Okay, I'm going to see if that is a problem with my code that builds my chains. So I'm going to put a breakpoint right in here, and I'm going to take a look at my chain. I'm going to see if that's correct. Okay, so if I look at my selector pointer, the list is nav, parent, ul, 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 li, li, li. Wow. Okay, there's something terribly wrong with my two-string implementation. Oh, wow. Seriously? You guys didn't catch that? Ugh. I was always invoking the get textual representation of selector on this class, or this object, not the actual children of it that it's inspecting. Okay, so the selector is nav parent ul. Okay, it looks like what we're missing here is that I don't have my relationship set up correctly. Because what it should be is nav parent space ul. There should be space on the ul. So that means that my selector relationship isn't... I have one too many of these selector relationship thingies. Whoops. Nope, that wasn't the right one. Honestly, what I'm doing right now is I'm just removing these selector relationships until I find the one that's causing the problems. What about you? Selector nav parent ul li active. There we go. That's what I wanted. So now our... Now what's funny is if you look at the textual representation here, they're both the exact same. The element, the way I printed out the element, happens to coincide exactly with how I printed out the selector. Which is cool, I guess. But that means we have a bug, obviously. So let's think about what happens here. We get our element, we check to see if it matches the selector we're looking at. If it doesn't, we move the element pointer forward, and that's fine. Then we move the selector pointer forward. If it's null, we return null. Then if it is not none, we move the element pointer forward. Now I'm thinking that should actually work. What do you guys think? Oh, I'm not looking at my right... derp. Okay, so let's go ahead and debug this and see where it breaks down. So the first element we're looking at is a navigation element with the ID of primary. The first selector we're looking at is an element selector with nav. This should match. Because it does match, we move our selector pointer forward, and what we get is a ID selector. So that's what we wanted. And so now we're still looking at the same element. And we're looking at, so now this element, which we're still looking at, the nav hash primary, should match this selector. But it doesn't match it. This selector is a ID selector with the ID of parent. This element has an ID of primary. Did I mess up my test? Oh. I did. Yeah, parent does not equal primary. Hey, look. Okay, so now we have a fairly complex combined selector here. I'm going to go ahead and go on break here real fast, and then when we get back, we'll go ahead and implement the immediate descendant selectors. And if you guys recall, if I take a look at my tree parser tests, I should have some tests for immediate descendants, and remember those are these things where the next element in the chain has to match the next selector, otherwise the selection will fail. So, yep. Okay, so we currently, what do we have implemented? We have our nested selectors, we have a differentiation between selectors that should match the same element, as well as selectors that should match any descendant element. So let's go ahead and write a selector that will have to match an immediate descendant. So I'm going to write another test. Public void selector with immediate descendant. Works. I'm bad at test names, sue me. I'm going to go ahead and write out the selector in CGS first to make it easier for me to write the actual object instantiation. So let's do something like nav primary ul and then a, and then let's write a DOM that looks like this. Nav with the ID of primary with a ul inside of it. Then have an li inside of that, and then have an a tag inside of that. Then I'm going to write another element that is not an immediate, that is not a ul immediate descendant to nav. That's just going to be a naked li with an a in it. And that. Okay. So the way things are, or how about a span? Let's do 3 elements. So I'll have a li with that, and I'll have another element that's a span with a ul in it with an a tag right inside of that. So I have 3 elements and only one should match. So let's write the selector first. The selector is going to look like, it's going to be an element selector, the element type of A. Then its parent is going to be another element selector with the element type of ul. Then the ul is going to have a parent of an element of an ID selector with the ID of primary. But the important bit about this is the relationship is actually going to be immediate descendant. Then the ID selector is going to have a parent of an element selector with the element type of nav with the relationship of none. So this object that I just instantiated will represent this selector. So that looks good. Next up we need our elements. So I'm going to create first of all, I'm going to create my nav. My nav is going to be an element with the element type of nav with the ID of primary. Then I'm going to create the A tag, which should be matched by the selector. So A equals new element of type A, and this needs a parent of a new element of type li, and the li needs a parent of nav. Then I'm going to write my A tag that's just sitting in an li tag. So second A tag is a new element of type A that is sitting directly inside of an li. So it'll have a parent with element type blah blah blah, and the li will be parented to nav. Then I'll write my third element with the third A tag is going to be a new element of element type I am going right to left, mostly. I hope. Yeah, I'll debug this test first to see if I'm actually getting this right. You know, okay, now you see the selector. Okay, there you go. What was I doing? The third A tag is right here. It's nested under a UL that's nested under a span. So this A tag has a parent of a new element with the element type of UL, and the UL is nested within an element with a new element type of span, and the span is nested underneath the parent nav. Let's make sure that I got all these right. I'm going to put a breakpoint at the end of my test, and I'm going to write it, or run it, or debug it, words. And then let's see if these actually work. Selector. Whoops. Do string. Okay. Nav, primary, sweet, that works. Then let's check my A. Nav primary LIA. Nav primary. Okay, I forgot to nest my LI inside of a UL. Okay, let's try that again. There we go. Now the A is nested in a UL, so this should match the selector. Then let's check out my second A tag. Whoops. Second A tag, nav primary LIA, which is LIA, good. Let's check out my third A tag, which is a in a UL in a span. Okay, awesome. So let's write our assertions. The selector, briefly explain the immediate window. The immediate window is really cool. The immediate window allows you to actually execute arbitrary C# directly wherever you're debugging on. So wherever your breakpoint is currently being hit, you can type in any arbitrary C# that you want and get a result. It's like a REPL, like something you would get if you used an interpreter like Ruby or Python. It has some limitations. It can't use dynamic, it can't use extension methods, and it can't use lambdas. I wasn't typing in arguments, I was typing in C# expressions. Like, if I bring up code completion, I can look at all of my local variables, and I can look at all of the methods on them. So I could do, what's the type of third A? It's A. I could have just hovered over third A and looked at its unique ID if I wanted to, but that's not as cool. But you can type in any C# that you want, almost any C# that you want. Like I could say new string B20, and I get an argument exception. Of course I do. But but you get the point. Okay, so the selector should match A. The selector should not match the second A. And the selector should not match the third A. Now, the way I've currently written this, the third assertion should fail. And it does. Sweet, so that was expected. So now I need to make it so the third assertion fails, but the first assertion is still true. To do that, I need to bring in the concept of an immediate descendant into my chains match method. And I'm going to express that in the form of a Boolean up top called must match or force match. Now, force match is going to, what it's going to do is if the relationship of the next element or of the parent is an immediate descendant, I'm going to set force match to true. And if force match is true and the next element does not match the next selector, that means that I need to fail, because that means it's not an immediate descendant. So what I'm going to do here is I'm going to say if not selector does match element, then I'm going to say if force match is true, then we return false. So if the previous selector had a relationship of immediate descendant and this element did not match that selector, that means it's not an immediate descendant and we need to just short circuit everything and return false. So how do we determine if force match should be true? Well, all I gotta do is I'm going to set force match to false by default. Then I'm going to say if selector pointer dot value dot relationship equals immediate descendant, then set force match to true. Which I could just do that actually. That works. And we get a success. So now my immediate descendant selector works. I'm going to do one more immediate selector test. Selector with multiple immediate descendants work. And I'm going to change this to have the UL A and then the A must have a span in it or something. So nav primary UL A span. Sounds like fun. Oh great, how am I going to write this? What did I change? So the UL, the relationship between the A tag and the UL tag is now an immediate descendant, which means I need to go all the way at the end of this and say immediate descendant. Then I need to wrap the selector in one more element selector with the element type of span. And then his parent is going to be what we had before. Okay, so at this point, let's think about it. At this point, every one of these should be false. Hopefully. Good. So every one of those is false. That's good. Let's introduce another element that is inside of this A tag that is a how about let's do a span, or no, how about let's do an H1 with a span inside of it. So I'm going to go ahead and do var span equals new element. The element is going to be of type span. He's going to have a parent to a new element of type H1, and the H1 element is going to have a parent of the first A tag. So the selector should match this. Let's see if that works. And it doesn't. Let's see, element blah, selector blah. Okay. The element is that, but we have a selector of now primary, immediate descendant UL, immediate descendant A. Oh right, I have an immediate descendant A, don't I? Which means I have to get rid of that LI element right there. So let's do that. I'm going to find that LI element that I have in my selector, or no, I have to find the LI element that I have in my thingy, and I need to delete you, and I need to delete you. Okay, so that works. So now let's write another one that is very similar to this, but let's break one of the immediate descendants. Let's break the immediate descendant between the UL and the A, which is actually already, because I forgot to delete the LI out of this. Okay, so then I'm going to create I'm going to create a span 2. The span 2 is going to be just like span, except for his A tag is going to be different. His A tag is going to be an A inside of a new element with the element type of LI with the parent of that. Then what I'm going to do is I'm going to say this should not match this. So this should be false. Run the test again. Okay, so it seems like we got some pretty complex selection action going here. We have normal descendants, we have immediate descendants, and we have no descendants. Forgot the syntax parent. Oh, what that's doing is this is an optional parameter that I'm naming. I'm just naming it to be a little bit clearer. With C#, you can name parameters now in your argument list if they're optional. Because if I look at the constructor to element, notice that the parent is set to null. Also notice that the parent is the last parameter to the constructor. But not only am I setting this to default, or not only am I overriding the default, I'm also specifying the parent as a second parameter, so I need to name it. Does that make sense? Yeah, well, it's naming a parameter. It was introduced in C#4, so it's not a very old feature. It's fairly new. Actually, we're already on C#5, aren't we? It's not in C++. I don't know. It shouldn't be. I don't know if I haven't looked too much about C++ 11 or X11, or I can't even remember what they ended up calling it. It used to be like OX or X08, then it was like X09, then it was X10. Yeah, I don't know what they ended up calling it, but I don't think that C++ supports named arguments. Or, yeah, named arguments. Okay, so next up, thanks. But next up, we gotta do pseudo selectors. So, how are we gonna test these? Public void hover. How do you spell pseudo? I hate this word so much. Hover pseudo selector. Okay, so the selector is going to look like this. The selector is going to be UL li hover A. I mean, that's actually, I've written this selector so many times in HTML, it's not even funny. So what this is going to mean is that it's going to select the li only if the li is in the hover state. So the corresponding HTML to this would be something like UL followed by li with a hover state. So I'm going to just put in that. I mean, that's actually not valid syntax, but I don't really care. This is pseudocode anyway. Okay, so let's write our selector first. What's that going to look like? Well, the selector is going to be a new element selector on a new element type of A, followed by a parent of a element selector with the element type of Li, but this selector is going to have a pseudo selector in it. How can we do this? Okay, let's not worry about that right now. I'm going to finish up the implementation of this. The next up is we have an element selector of element type UL. Okay, and then our element is going to look like this. We're going to have a which is going to be a new element of type A with the parent of a new element with the element type of Li. Now this element is going to have a pseudo class of hover and a parent of a new element with an element type of UL. Then I'm going to create another A. I'm going to create two A's. So A1, A2. And the only difference between these two is that one's going to have a pseudo class on it and one's not. So that means my selector should match A1. But it should not match A2. So let's run this test. And we get a failure. So the first one matches, but the second one does not. So let's go ahead and fix that. The first thing I need to do is I need to have my selectors take in a potential collection of pseudo classes that they have to select on. So what I'm going to do is I'm going to go back into my constructor of my selector, and I'm going to add a new parameter. That parameter is going to be an IEnumerable of string called SPSEUDO classes, and it's going to default to null. Then I'm going to create a private read-only IEnumerable of string called PSEUDO classes, and then I'm going to set pseudo classes to pseudo classes, or if pseudo classes is null, I'm going to set it to an enumerable of empty of string. Actually, I'm not going to have that allowed to be null. I'll have it allowed to be null on the people that inherit from that. Okay, so we have an item classes, blah blah blah, pseudo classes equals null. Pass in pseudo classes into that. So we got that working. Next up, we have to do the same on element selectors. Next up, we need the same on ID selectors. Okay, so now we have the constructor parameter in place. So now in my test, I can actually write a test that will specify that this element selector of type Li should only match if the element has a pseudo selector of hover, or a pseudo class of hover. I can't remember if that's even the right terminology. Wow. I'm pretty sure it is. So the pseudo classes is going to have a hover, and then the parent is going to be that. So that should actually not affect my tests whatsoever. It should still fail. Good. But the difference is now I actually have the information of what pseudo classes need to be present on an element in order to match it. So that makes things really easy, because now what I can do is I can, let's see here. So if it does match the element, but it doesn't match the correct pseudo classes. So what I'm going to do is I'm going to say underscore, oops, whoop, no, yes, good. So selector pseudo classes sequence equals element dot pseudo classes. So if they do not equal, then we immediately return false, because the pseudo classes don't equal each other. And we now have a passing test. Okay, so we've done pseudo selection, or pseudo classes, we've done immediate descendants, compound selectors, I don't even know if that's the right name for it. We've done descendant selectors. What else do we have? I think that's pretty much everything, right? And it's pretty much everything that our language actually parses out of a selector. We have our selector type, which could be a class ID or element selector. We have our selector relationships. We have our pseudo selectors. But we do have a problem, actually. Let's think about this. No, we don't. Maybe. Depends on the implementation of sequence equals. Looks like sequence equals actually, oh great, it does require the order. We need to make sure that every single pseudo class that our selector has is present in the element. So I think the easiest way to do that would be to say if pseudo classes accept this any. So if pseudo classes of the selector accept the ones that are present on the element, if there are any left over after doing that accept, then we return false. Let's run our tests again. Oh, there we go. Okay. I think that's pretty much going to wrap up what I wanted to do today. There's a lot of... Well, yeah, like for example, if an element, let's say an element is hovered over and it's the first child of a sequence and it's the first child of type. I don't see any reason why you couldn't do that. I mean, I can prove to you it works, which I'm 90% it will. I've never done it before, but I'm sure it'll work. Give me a sec. Let me toss up a bogus HTML file and see if... .html. Edit with Sublime Text. Okay, so let's be lazy and copy and paste the doc type in HTML, get rid of that, style, I don't know, li hover first child, background red, ul li first child, li second child. And for some reason, Internet Explorer hijacked my default browser. But we can see an example of this working. Notice how the selector only matches if it's both hovered over and it's the first child. I've never done anything like this before myself, but it does work. So, might as well make CGS support it. But do you see what's going on there? Oh. Well. Huh. I wonder if NATO's paying attention. Oh, there he is. How am I getting the first child? Through the first child pseudo selection right there. See that? The selector is only matching. I wouldn't call it a keyboard or keyword. A keyboard. I wouldn't call it a keyboard either. Yeah, I wouldn't call it a keyword. It's just a pseudo selector. There's a bunch of ones you can use. You can use first child, first of type, nth child. Yeah, it's defined by CSS. Which means with CGS we can define whatever pseudo selectors we want, although currently we'll only be supporting active and hover. Active for being pressed and hover for the mouse hovering over it. But there's no reason why we couldn't support first child and last child and all that stuff, and we would want CGS to be able to handle that scenario. Which, let's try to test for it. Multiple pseudo selectors work. Let's do li hover and then first child. Let's say li hover first child A. Let's do something different with this one. I'm going to give the first one a pseudo class of hover, and the second one I want to give a pseudo class of hover and first child. Although pseudo class currently doesn't support enumerables, does it? I'm going to change that. Pseudo classes. Okay, so pseudo classes we can now pass in multiple of them in. Let's do that and that, and then let's give this one a hover and a first. No, let's give the first one a hover and a first child. And we get a failure. Oh, that was a good idea. I went ahead and wrote this out. A2 should be false, but for some reason it is true. Oh, I never changed the definition of my selector. Yep. There we go. Multiple pseudo selectors can be applied now. Okay, well, I'm pretty happy with how this aspect of everything is working. So next week what we're going to do is we're going to combine everything together, because we basically have two major, like, I guess you could say, subsystems. We have our compiler, which is tested by both the parser tests and the tree parser tests, and we have our selector implementation done. But what we need to do now is we need to write implementations of our builders. And if you recall, our builders are being invoked by our tree grammar. Because if you look in our tree grammar, you'll see that things like create style are being invoked, and things like push descendant or push immediate descendant, or set class selector, set ID selector, set element selector, and all that fun stuff. That's all being invoked on our builder interfaces. So what we need to do is we need to create a concrete implementation of our builder interfaces that construct a representation of our selectors in the way that you see right here, with instantiating all of our selectors like this. So that means we'll be able to actually use the language itself to construct our selectors and not have to rely on this horrible syntax, which is really just there for internal use. But I wanted to make sure that my selection stuff was all solid before I put together a builder. Okay, so how's everyone doing? Yeah, again, you would think that the ANTLR stuff would be the most complex stuff, but even though if you just take a look at the actual implementation of the method that determines if a selector matches a particular element, it's actually rather small. I mean, it's only, what, 30 lines of code, maybe a little bit more than 30 lines of code? And yet it is capable of performing some very complex tests against elements. Oh, well, that's not good. But I think that wraps up everything that we can go ahead and do tonight, because putting together the builder interfaces is going to take some time, because then we have to write tests that what we'll be able to do basically is instead of doing this, which is horrible, we will be able to do this, which is awesome. So to all you future people, I will see you next week.